Hey everyone, hope you're having a great weekend so far. A few of you reached out about getting some extra practice with atomic structure, or maybe you wanted to see a recording of class last week. So great time to go over a few extra things and help you feel great going into the week ahead. So first things first, you'll definitely want to have a periodic table handy. And if you don't have a hard copy, then you should go to our class course resources page here, Honors Chemistry, course resources, and you'll see we have a calculator and a periodic table. You might need both today. So I'm going to go ahead and open this in a new tab, okay? All right, secondly, if you missed class last week, you definitely want to go in and go through the Nearpod. So if you go to modules, you'll see we're in Unit 1 and the Nearpod slides are here. So you can go through that. And now for everyone that's trying to do extra review, let's switch into looking at this build an atom simulation and see what we figured out. So we figured out a few things about protons. Every time you add a proton, the identity of the element changes, right? So on our periodic table, hydrogen is atomic number 1. It has 1 proton. Helium is atomic number 2. It has 2 protons. Lithium, number 3, 3 protons. Beryllium, number 4, 4 protons. Okay, so we figured out a few things. We figured out protons, each proton has a +1 charge, they're positively charged. We figured out they're located in the nucleus, inside the middle here. And we figured out that every time you add a proton, you have a new name, a new identity of the element. Neutrons don't seem to change the identity of the element, and they don't seem to change the charge of the atom, but they do change the mass, right? So we figured out that neutrons are neutral, they have no charge, they are located in the nucleus, and each neutron has a mass of 1. And we call those atomic mass units because it helps simplify things rather than weighing them out. It would be like 0.20 zeros or something really tiny. Okay, great. Now what about electrons? Do they go in the nucleus? No, it won't let me put electrons in the nucleus. I keep trying, but they are actually represented in orbits, or sometimes it's called a cloud. They're outside the nucleus, and they seem to have a, what kind of charge? If you said negative, you are absolutely right. So the protons and the electrons are the parts that have charges. Protons have a positive charge. You can remember P for proton, P for positive. Electrons have a negative charge. And remember that opposite charges attract. So these electrons are sort of held around. They don't just go flying off because the protons are kind of pulling them in. All right, great. And so we can add as many electrons as we want, but you can see that it becomes what's called an ion after you have more electrons than protons. What about if you have fewer electrons than protons? It also becomes what's called an ion, but now it's a positively charged ion. So there seems to be a balance between protons and electrons. When you have equal numbers of them, you have a net charge of 0. But when you have more protons than electrons, you have a positive charge overall. And when you have more electrons than protons, you have a negative charge. And it depends on how many more. Like here's 2 more electrons. So it has 2 more negative parts than positive. It has a -2 charge overall. Okay, we summarized this into a little, we did a little matching, and then we summarized this in a little table about location, mass, and charge. And so, as you can see, parts that have mass are the protons and the neutrons. So when we talk about the whole mass of the atom, we have to add together the protons and the neutrons. Electrons are so tiny that we say they have no mass at all. They don't play a role in mass, but as we said, they do play a role in charge. Okay, that was kind of a review of what you did with the sim last week. Now we want to look at this symbol part. So there's another part to the sim, and it's called symbol. So if you go back to that link that we played with on the introduction to atoms last week, then you can click at the bottom, there's a part called symbol, and that was the thing we did next. So we tried to figure out what these symbols mean, because this is often how the atoms symbols are written, and so we want to know what it means. All right, so let's just try adding one proton. When there's one proton, it's hydrogen. That's the element symbol is H. When you add another proton, it becomes helium. Okay, so similar kind of pattern here. What changes when we add more neutrons? This top number. And this top number must be then the mass of the whole atom, because there's 4 particles in the nucleus. 2 protons plus 2 neutrons gives us a mass of 4. Now, right now, there's only 2 positive particles, right? The neutrons have no charge. So when we think about charge, right now there are 2 charged particles and they both have a positive charge. So this helium atom overall has a +2 charge. When we start adding electrons, 1 electron balances out 1 positive proton, but there's still 1 more positive charge than negative charge. So overall it has a +1 charge, and it's called a positive ion. If we add another electron, now it's called neutral, because there's the same number of protons, 2, as electrons. Okay, what if you had 3 protons? Then it would be lithium, right? Atomic number 3. And 3 electrons. Still neutral, right? Because they're balancing each other out. What would the mass be? Well, this lithium has a mass of 5. Remember, the mass is just the protons plus the neutrons. Okay, great. I want you to take some time just to play with this, because interacting with it will help you much more than me explaining it to you. So go ahead and pause and just interact with it a little bit before we look at the actual practice, okay? Okay, and then here's our extra practice, so you can so we can see how we did. Okay. All right. So first part is easy enough, matching, right? Electrons, where are they found? Not in the nucleus, right? They're outside the nucleus. They have a negative charge, so that's going to be C. How about neutrons? They are in the nucleus. Do they have a positive charge or no charge at all? You got it. They are neutral. And so then the protons must have a positive charge and be found in the nucleus. All right, great job. Now let's ask ourselves which 2 subatomic particles, protons, neutrons, or electrons, contribute to atomic mass. And so I hope that you know that those 2, the ones in the middle that have a mass, are the protons and the neutrons. Okay, great. Now, if you didn't do well on the exit ticket, or you're just here for a little bit of extra practice, this is where you really want to see what you know here on the symbol part. Okay, so you'll need your periodic table, and you may need a calculator for this part as well. Some of the numbers get a little big. I want to walk through at least the first two together, and then we'll see how you can do on the last two. Okay. All right. So just like we were doing in the simulation, you'll be given a symbol, and you know that the number at the top left represents the mass, and the bottom left down here represents the atomic number. So let's go ahead and look at your periodic table. What is atomic number 53? If you're saying iodine, you're right on. It is a liquid at room temperature. It's a brownish liquid. They use it to prepare for surgeries or to clean skin before some kind of procedure. So it is atomic number 53. Now we know the atomic number is always the number of what? The number of protons. You got it. So the atomic number and the number of protons are always the same. If it's if like let's say iodine somehow got another proton fused into it and had 54 protons, it wouldn't be iodine anymore. It would be xenon, right? It would be number 54. So if it's number 53, it has to have 53 protons, and it has to be iodine. All right, now the mass they told to us. It's right at the top of the symbol. It's 128, so that's easy, just filling it in. And what do we know from question number 2? Atomic mass equals the number of protons plus the number of neutrons. So we need to do a simple subtraction problem here. We know protons, 53, plus neutrons, that's what we're trying to figure out, equals 128. So 53 plus X equals 128. What is our number of neutrons? Just do 128 minus 53, and you should get 75. So they're not always the same. The number of protons and neutrons are not always the same. In numbers like atomic numbers up to about 20, they're usually really close together. After that, things start to get heavier, and we'll talk about why that is later. Okay, now let's double check that it makes sense about the number of electrons. They did fill it in, but we could have figured it out also. If they told us the overall charge of the atom is -1, that means that there's one more negatively charged particle than positively charged particle. So that means that there's one more electron, because those are negatively charged, than proton, because those are positively charged. So does it make sense? If there's 53 protons, there should be 54 electrons and one more negative particle. Yeah, that will give you a -1 overall charge, right? All right, awesome. How'd you do? Let's try the next one. Ooh, this one, we get to write the symbol, okay? So that's kind of fun, a little different. We're starting with atomic number 14. All right, so look on your periodic table. What is atomic number 14? Did you find it? It's silicon. It's right underneath carbon. The two are really similar, and we'll talk about why that is later. Its abbreviation is Si. Okay, so we'll write that. And you know that the atomic number goes at the bottom left, so that's 14. We know that the atomic number is always the same as the number of protons, right? So if it's number 14, it must have 14 protons. Those are it's what it's based on. Okay, now we know the mass is 28, so that's going to go at the top left. And if we know the mass and we know the protons, we can figure out the number of neutrons, right? So the number of neutrons is mass minus number of protons. So 28 minus 14 is 14, okay? Now, for the charge, what do we have? Let's look at the two parts that have charges, protons and electrons. We have 14 protons and we have 14 electrons. So we have 14 positive charges and 14 negative charges. Those balance each other out. So the net charge of the whole thing is 0. It's kind of like if you got $14 from a friend, but you already owed $14 to somebody else, you don't really have any money, right? So even though there's 14 positive protons, there's also 14 negatively charged electrons. So the overall charge is 0. If it helps you to write 0 here, you can. But as you get further along in this, you'll see that we actually just leave it blank. If the charge is 0, you actually just don't write anything in. It's assumed that there's no charge if there's nothing written there, okay? All right, let's do 2 more and then we'll call it a day. We're looking at atomic number 8. It has an abbreviation of O. What is it? Oxygen. Nicely done, a very important one. So it's atomic number 8. It has 8 protons. That's the definition, right, of the atomic number is the number of protons. And its mass is given in the top left corner. So this oxygen atom's mass is 18, which means if the mass of the whole nucleus is 18 and 8 of that is protons, how many of it must be neutrons? We've got to do 18 minus the 8 that are protons. There should be 10 neutrons. So remember, protons and neutrons together equal atomic mass. So is 10 plus 8, 18? Yeah. Okay, nicely done. Now, last thing is electrons. Okay, look. What is the charge of this oxygen atom? It's written in 2 places. You got it here, -2. You also see it here, right? -2. So what does that tell you? That tells you that there's 2 more negative particles than positive particles because it has 2 more negatives than positives. And you already know that there's 8 positive protons. So there must be 10 negatively charged electrons because it's 2 more than the positive parts. So if it helps you to think about it, for calculating charge, you can do protons minus electrons. Is 8 minus 10 -2? Yes. All right, you guys are rocking and rolling. We've got 1 left to go over. Let's give it a shot. Its number of protons is 19. What else is 19 then? Which of these other boxes is 19? Atomic number, you got it, number 19. And so then let's look at your periodic table and figure out what is number 19. It's one of the metals that we watched the video of. We saw it reacting. It's potassium, and it's another one that doesn't have the same abbreviation as the letters in the name. So its abbreviation is actually, or symbol is actually K. Okay, so we already know that its atomic number is 19. That goes down here. Now, how do we figure out its mass? They didn't tell us this time. So this time we have to figure out mass. Which 2 particles do we need to add together? We've got to add the protons and the neutrons. Nicely done. And so what's 19 plus 21? 40. And that's going to be its mass that goes at the top left of the symbol. And also in this box here. Okay, great, we're almost done. Let's take a look at the charge. Remember, the two parts that have charge are protons positive, electrons negative. So we're looking at 19 positively charged protons and 18 negatively charged electrons. So what does this tell us? There's one more positive, right? There's one more positive part than negative part. 19 is one higher than 18, and these are the positives. So don't forget to go back and put it on your symbol. This potassium ion is a positive ion, and it has a +1 charge. All right, let me know if you have any questions on this video. Let me know how I can help you if you're having any struggles with chemistry so far. My goal is that everyone is getting this, succeeding, and having a little bit of fun. So please be in touch and let me know if at all I can help. Thanks, everybody.